Hello class, let's take a look at Chapter 4 on Network Security Fundamentals, and I'm going to start at the module introduction. We're going to learn about digital certificates. We're going to describe what PKI is all about, public key infrastructure. We're going to look at some security for your information in transit, communication or transfer protocols. Your data as you encrypt it, right? You can't then read the routing information anymore. The routers don't know where to send it, so you have to encapsulate it, basically. And that's why you have transport protocols. And we'll learn some characteristics of cryptography to how to implement it in a smart way. And that has to do with some of the attributes of the cryptography, the security, and things like that. So let's go to 4.1b, I guess. Let's start here. And this has to do with defining a digital certificate. So we know what a digital signature is, right? And it's a hash. And to demonstrate that, let's just put this right here. I'm going to type in something, Willy Wonka. Let's say that's my, that would be my signature, right? Willy Wonka. And this is the output. This is the SHA-256. This is the hash just from those two words. That could be a 10-page document. I'm still going to have the same length of hash. It's an algorithm that's been applied against this content, and I get a hash of value from that. Well, let's say I change this. Now, what does this end with? E45B. I'm going to put an L. Well, this is no longer ending in E45B, right? Gone. It's now DFC5. Let's get rid of that. What is it now? EF5B. Changes. I just changed a few characters, and the output from the hash changes. So that should illustrate what a hash does for you. Given and applied against your data, your information, it comes up with a mathematical calculations to render a hash value. And if you were providing let's say a 10-page paper on a website, and you were having people download it, once they downloaded it, they could run that entire paper against this SHA-256 hash. The content would be put in here, and you would render out a value. Now, if that is the same value that I downloaded against the file that was up on the server, they were the same, I know I got the complete download file. It's intact. All right, I can guarantee the authenticity of that information. That's a hash. That's what that is, right? So now we know. Now, a digital certificate, what it does, it takes that to a new level, basically. And it says, you know what? I still don't know that you're the one that created that 10-page paper. I need proof that you are that person. And the example the author gives you in this chapter has to do with the passport. You're vetted against your documents like your birth certificate and license and things like that to be checked out to make sure you are who you say you are. And that's what a digital certificate is. It's that third party, a trusted third party, that vets your information to guarantee you are who you say you are. That's what it is, right? And I think it'll come down here, and it gives some examples of someone intercepting it with a new public imposter key and all that. But a digital certificate it's a technology or the methodology used to associate my identity with my private key to a public key, by a trusted third party. That's what it is. That's basically it in a nutshell. All right, so digital certificate, trusted third party. Think that when you see that. Now let's look at PKI. Let's take a little look at that. Let's come here, and because with all of these certificates and encryptions and public key and private keys, we have to have a way of managing all of this. And that's just like you might have a keys to a skyscraper, and the rooms in a skyscraper, and that's got to be managed somewhere with physical keys. This is done like on the internet, basically. It's a public key infrastructure to manage who has the keys. It uses software and processes and people and procedures to manage, distribute, store, and even revoke digital certificates. They can be revoked. If there was a problem with the certificate, or it's expired, then it's revoked. That's what happens. So public key infrastructure, let's take a look at that. And okay, we talk about trust models, so we'll go through a couple of trust models, and just at a high level, you directly trust another person. That's direct trust, right? If someone recommends a company to you to do maybe clean your car or clean your house, you've had a referral from someone you trust, from a friend, and then you go and try that company. All right, so that's a third-party trust. That's what that is. So some trust models, when it has to do with public key infrastructure, or PKI, has to do with a hierarchical trust, right? Like in this case, there's a certificate authority that signs all the certificates and said that's authentic, and we trust that. You've been vetted as the owner of the certificate, so we're going to go ahead and use you. That is great as long as you're not taxed and overwhelmed. If you are, then probably a distributed trust model would work better, where you have intermediate certificate authorities that you can grant permission to sign off on certificates or revoke them if needed, and distribute the workload basically. And then you have the last one here is a bridge trust model, where you have a certificate authority, a bridge certificate authority that doesn't actually authorize certificates or revoke them or any of that. It just links one certificate authority with another, right? So it's kind of a conduit between certificate authorities. And okay, so let me go past that. Let me go to section 3 and jump to that. Okay, so 3 talks about data and being transported on a network, right? If you encrypt data so then it cannot be read, how do those packets travel on the network? When Mr. or Ms. Router takes that packet and looks at it, it can't see where it came from or where it's going to go, right? So there's got to be some certification, or in this case we call it encapsulation of the data. We'll take that encrypted document and we're going to, if it were an envelope, we're going to stick it inside another envelope where we can address where it came from, where it's going to. So think of it like that. It's a transfer secure layer security. Now, early on we had SSL, or socket layer. It was found to be vulnerable. Then we're going to have one after TLS, transfer layer security. It's been enhanced. It's now 1.3 and it's gotten better. But notice that it removes support for what I showed you earlier, SHA-224, right? We now use SHA-226, as I showed you earlier, where we looked at a name. Okay, so as security improves, the bad actors get better trying to hack the security, and then we have to improve it, and so it's a bit of a leapfrog process here. So TLS 1.3 is the newer one, and it removes support for some older protocols there. So, and they use what's called a suite of security information to kind of make sure it's secure. Then we have IP security, or IPsec, right? And that's another a set of encryption and authentications that actually looks at each packet of data as it transfers on the network, that makes sure it really is secure. There's nothing hidden in there. So that's 4.3a. Let's see, what else do I need to do? Let's go to the last part of this. Let's go to as far as implementing security. How do we judge how good the security is, right? And it has to do with how random and non-predictable are these encryptions. As they get studied and hit against with the bad actors and try to break them, then we learn at some point that they're no longer secure, and we make them better or replace it with another one. Another characteristic we look at is the cryptography period, or crypto period. That is that we only want to use it for a limited amount of time to give the limited exposure to this type of cryptography, so there's less of a chance they're going to hammer it and hack it, right? So that's crypto period. And the key length, the longer the key length, the better. The longer it's harder to hack, as you might know. That makes sense, right? And the other thing is, let's go here to the summary. This is a really good section. It talks about digital certificates and how they work with the public key and private key. It's a good one to look at here to start at. And let's come down to certifying and verifying their certificates. Depends on certificate chaining, linking several certificates together, establishing trust. We learned about the different types of trust: hierarchical, distributed, and bridge, different trust models. What else? PKI, we talked about that a little bit, and that's the key management system for these public and private keys. And there's got to be a good system to keep track of all that information, and that's what PKI is. So you're aware of that. And what else? Algorithms to protect your data in transit, and that's called transport protections or algorithms. And we had SSL, secure sockets layer, and they learned about the TLS, or it's transport layer security, and then IP security after that, right? And another form of security we know about when we're on the internet and we're entering our password into a website, we're logging on, instead of HTTP, hypertext transfer protocol, we know that we should see HTTPS, S for security, to know that our data, after we key it in, hit enter, it's been encrypted as it travels across the World Wide Web to get to the server that it's going to. That is chapter 4. 4 really big concepts we learned in this chapter. Try not to get too overwhelmed by it. I showed you how to do the encryption and with the SHA-256, so you can kind of see it. There are tools online where you can do that, and you can get you can apply for a certificate yourself. And some services do it free for 30 days, and then you pay for it after that. So anyway, if you have any questions, let me go back to the start of this book and the introduction. All right, this is it. This is advanced cryptography. Let me know if you have any questions. All right.